This is from the 2024 exam. This is a Taylor polynomial from that year. So they give us a Maclaurin series right here, and it converges for all f of x within the interval of convergence. It is known that the Maclaurin series for f has a radius of convergence 6. Determine whether the Maclaurin series for f converges or diverges at x equals 6. So basically what they're asking us to do in part A is to check our endpoints, because if we were centered at 0 and our radius of convergence was 6, we're considering this endpoint right here. B, it is shown that f of -3 is equal to that, so all they did here was plug in -3 in for x. They simplified it. It is shown that the first 3 terms have this sum. So they want you to show this value, that the absolute value, and this is your real value. This is what you approximated. So what they're basically asking you is for the error. Part C. Find the general term for the Maclaurin series for f prime, the derivative of f. Find the radius of convergence for the Maclaurin series for f prime. Part D, use the ratio test to determine the radius of convergence for this Maclaurin series. So now we have a slightly different one. So in part A, we have that f of x is equal to the sum from n equals 1 to infinity of n plus 1 x to the n over 6 to the n, and they want us to check the convergence for x equals 6. So all we're going to do is plug in 6 into our polynomial. So it says n squared, sorry. So we get n plus 1, 6 to the n over n squared, 6 to the n. Notice those 6 to the n's cancel, and we're left with n plus 1 over n squared. This is basically behaving like 1 over n, so this diverges by comparison to a p equals 1 series. So looking at part B, we know that f of -3 is this. They want us to show that this is true. So again, this right here is our approximate. Now we know for an alternating series, the error is less than the first omitted term. So for a convergent alternating series, the error is less than the first omitted term. So looking at our problem, we use the first 3 terms to find our approximate. So we're going to use our 4th term. So our error is going to be less than, and we're going to plug in n equals 4, because it's the 4th term is going to tell us that was the first one that was truncated. So if n is equal to 4, I'm going to have 5 over 16, negative 1/2 to the 4th. So we know that's equal to 5/16 times 16. And that is definitely less than 1 over 50. So the first thing we wanted was the general term. So let's go ahead and write out what that is. So part C, we know that f is equal to this. And we're going back to the original f of x. Do not use f of negative 3 that we did in the previous part. So they want us to find the general term for f prime. So remember, the only thing that happens when you take the derivative is the power on the x comes in front and you subtract 1. So the general term would be n plus 1, n squared, and then we'd have another n, x to the n minus 1, over 6 to the n. So that's our general term. Now notice that sometimes you lose a term when you do your summations and take derivatives. Sometimes you can lose a term when you take derivatives or integrals, but they only ask for the general term, so you don't need to write this. This right here is the general term. The next thing they want you to find is the radius of convergence. So to find the radius of convergence, we always use the ratio test, unless it's geometric. So an plus 1, so n plus 2. And I'm going to go ahead and cancel these to make it a little bit easier on me. Just put n down here. So that would be n plus 1, x to the n, 6 to the n plus 1, and now we multiply by the reciprocals. We go through and we cancel whatever we can. So we have an extra x on top. We have an extra 6 on the bottom. And then we ask ourselves, are the degrees equal? Yeah, the degree of the top is 2 and the degree of the bottom is 2. So this is left with the absolute value of x over 6, which is less than 1. So we know our radius of convergence is 6. It is also noted that we could have just said it's r equals 6 because taking a derivative or an integral of a series does not change the radius of convergence. It does change the interval, the endpoints, but that does not change the radius. But again, it wants us to find the radius of convergence. So this series looks like g of x, so n plus 1, x to the 2n, n squared, 3 to the n, and of course this starts at n equals 1. So we're going to use the ratio test. So n plus 2, and this would be x squared times the quantity n plus 1, n plus 1 squared, 3 to the n plus 1, multiplied by the reciprocals. And now we go through and cancel whatever we can. So first, looking at the 3 to the n's, I have an extra 1 down here. Now we got to be super careful here because this is really 2n plus 2. So when I cancel this one, I'm left with x squared. Now we check, are the degrees equal? Let's see, on the top I have degree 3. On the bottom, here's 1, 2, 3, 2, and 1. So they're both degree equals 3. So we're left with the ratio of the leading coefficients. So it's going to be absolute value of x squared over 3. Remember that we need this to be less than 1. So then x squared's got to be less than 3. So x would be less than root 3. So our radius of convergence is root 3. So now let's go over the scoring for this one. So on part A, you got 1 point for considering this and 1 point for the answer. And again, they don't go through and show the limit comparison test unless they physically say use the limit comparison test to show this. You just cite it. Part B is worth 2 points again. So 1 point for using the fourth term, which is right here, the fourth term, and 1 point for finding the error. Part C is worth 2 points, 1 for the general term of f prime, so I guess it's this one. And then the second point comes from the radius of convergence. And then part D is worth 3 points. 1 for setting up the ratio, 1 for finding the limit, 1 for finding the radius.